Hey guys, we'll take up one more problem on linearity property of a system. In lecture 2, I solved first problem where I took a system which was linear. Now I'll take up one more problem, second problem, where the system is non-linear. So y of t is equal to g of t plus x of t. So this is the system solution. What is the first thing I need to do? I need to get desired output of a linear system Now as per the linearity property, transformation of x of t is equal to y of t. This is the standard form we usually write uh, or we usually represent the system input output. So transformation of x of t is equal to y of t. And what is y of t? Y of t is g of t plus x of t. Okay, now if this is the case, what is transformation of x1 of t? So it is nothing but g of t plus x1 of t, right? And what I do, I'll scale the input a times x1 of t. If I feed this as input to the system, what is the output? It is nothing but g of t plus a times x1 of t. Instead of writing x1 of t, I'll write it as a times x1 of t, and the right hand side also accordingly will change. And what is this? This is nothing but a times y1 of t. For every scaled input, I should get scaled output. So similarly, what is the transformation of b times x2 of t? This is nothing but g of t plus b times x2 of t, right? And what is this? This is nothing but b times y2 of t. Now I'll combine these two, a times x1 of t plus b times x2 of t should result in a times y1 of t plus b times y2 of t. And how did I write this equation? This is from linearity property statement, right? Principle of superposition. And this is equal to what is a times y1 of t, which is nothing but g of t plus a times x1 of t, plus what is b times y2 of t? It is nothing but g of t plus b times x2 of t. So if I simplify it, g of t, it is nothing but 2 times g of t plus a times x1 of t plus b times x2 of t, right? So this is the desired output of the system, of a linear system. This is what I'm expecting if the system is linear. This is the output I'm expecting if the system is linear for a combined input a times x1 of t plus b times x2 of t, right? What is the next procedure? Yes, I need to get equation 2. And what is that equation 2? Equation 2 is nothing but the system output, right? So we'll try to get it. So to get system output, now as I told you in lecture 2, in order to get the system output, I should understand the system, right? So what is the system? System is y of t is equal to g of t plus x of t. So it is nothing but transformation of x of t. If you feed x of t, I get x of t. Whatever the signal you feed, for that signal, g of t is getting added, right? In the previous example, we had x of t into g of t. Whatever the signal I feed, it was getting multiplied. Now it is getting added. If I feed a sine wave gets added with some arbitrary signal g of t, right? So let me just give an example. say x of t is a sine wave which is varying from minus infinity to plus infinity. Okay, if I feed this sine wave to the system, what is the output? That sine wave getting multiplied by g of t, and we'll assume g of t as a unit step function u of t, which is varying from, sorry, this is 1, this is 0 to infinity, right? Okay, now what is the system output? Y of t is equal to g of t plus x of t, right? So what happens? What if I add these two signals? Okay, 0 plus this signal is, I get this signal as it is, and 1 plus this signal is, the signal shifts up, right? So it's like this. So negative time side signal remains as it is, whereas positive time side it is DC shifted by 1 volt. Okay, this is how the system output looks like if the input is sine wave and the g of t is the unit step function. So whatever the signal I feed, for that signal g of t is getting added. That will be my output y of t. Okay, this is what happening to the system. Now what I do is I'll feed, if I feed x1 of t to the system, what is the output I'm getting? So whatever the signal I feed, for that g of t getting added, right? So x1 of t for the given signal, g of t is getting added, right? So what if I feed scaled version of the input? What if I feed a times x1 of t? So for this signal, a times x1 of t was the signal fed. For this, g of t is getting multiplied. So this is the output from the system for the input a times x1 of t. Similarly, what if I feed scaled version of b times another signal x2 of t? What do I get? Same signal b times x2 of t, whatever the signal I fed. So for that, g of t gets added. Correct now? Yes. Now if I combine these two, a times x1 of t plus b times x2 of t. Okay, what is the output from the system we are expecting? So as a whole, this is one signal, right? Scaled version of one signal is getting added with scaled version of the other signal. When I add these two as a whole, this is one signal which I fed it to the system, right? So for that, the signal, that is nothing but this one, a times x1 of t plus b times x2 of t. So for this signal, what happens? G of t is getting added. Correct now? Yes. Now if I simplify it, g of t plus a times x1 of t plus b times x2 of t. So this is the system output what we are getting, which we call it as equation number 2. So the desired output for a linear system is something like, desired output of a linear system is equation 1, which is 2 times g of t plus a times x1 of t plus b times x2 of t, and system output what we are getting is g of t plus a times x1 of t plus b times x2 of t. So what is your conclusion? Therefore, since equation 1 is not equal to equation 2, therefore it's a non-linear system. It's a non-linear system. Okay, I'll take up some more problems in the next videos.